Hello, welcome to lesson 5. In the previous lesson, we were introduced to inferential statistics and hypothesis testing. In this lesson and subsequent lesson, we'll be looking at each of the hypothesis tests one after the other and look at how to perform them in SPSS. In this particular one, we are starting with the one sample t-test. That is what we are going to look at. We'll look at when to use it, some assumptions of the one sample t-test, how to perform it in SPSS, and how to interpret the result as well. So let's jump straight into it. When do we use the one sample t-test? It is used to compare the mean or average, or it compares the mean or average of a single sample to a known value or population mean. So the single sample here can refer to any of our variables here, but since we are talking about mean, we cannot include the gender because it's not a numeric variable, and we calculate mean for only numeric variables. We cannot compute mean for a non-numeric or categorical variable. So the single sample can refer to the age here or the height. There's a population mean or a known value which has already been established, and we are trying to compare our sample mean to it, or we take a sample and we want to find out whether our sample mean is equal to the population mean or not. So here we can find the mean of the age or the height depending on which one we want to use, and that will be our sample mean. Then we try to compare it to the population mean to see whether it is equal to or not equal to the population mean. How did we come by this population mean or known value? The population mean is probably from a previous study and it has been established as the mean or the population mean. In our research, we took our own sample and we want to compare the mean of this our sample to the population mean to see whether there's a significant difference or not. And the term population mean used here does not mean that when the previous study was conducted, the entire population was used. But in statistics, what we do is we take a sample from a population, a representative sample, then the measure we get for the sample, we use it to make inference or generalize it for the population. So the population mean used here does not mean that the previous study used the entire population. And definitely use a sample as we are doing here, but because we use it to make inferences or generalize for the population, that is why the known value is being referred to as the population mean. So let's say after our research, somebody also wants to compare their sample mean to this sample mean from our data. They are going to refer to this our sample mean as the population mean, because after our study we are also going to generalize our sample mean for the population from which we took the sample from. So that is why it is referred to as the population mean. I hope you get that. Another thing to note is that when we find our sample mean, it's definitely going to be different from the population mean. So if it's going to be different just by looking at it, why do we still need to perform the one sample t-test? The reason why we are performing the one sample t-test is that we want to find out whether the difference between the sample mean and population mean is statistically significant. Because the difference that we might observe just with our eyes could just be due to chance or probability or variability in our data set. That is why we need to perform the test to see whether the difference that we observe is statistically significant or not. So let's continue. So to perform the one sample t-test, you only need data set on one variable like the height as you have here or the age. You can use any of these since they are all numeric variables. But in this lesson, you are going to focus on the height. We are going to use the height as our single sample and we compare the mean of this sample to the population mean. So our single sample should be numeric variable or it should be a scale variable. And apart from considering the level of measurement for a variable, every statistical test has its own assumptions. So let's look at the assumptions for the one sample t-test. One is that the data should be continuous and it should be from a random sample. So continuous data is the type of data that is mostly measured, like height, weight, time, temperature. All these are continuous variables. And continuous variables can take on any value within a specific range. What it means is that they can have decimal places or they can be in decimal numbers. Age here is also a continuous variable because you can have two people having their age to be 35, but the months can be different, so we can have points as well in the age, which makes it a continuous variable. The next assumption is that the scale or level of measurement must be interval or ratio. Then next, the observations should be independent of each other. That means the height of one person should not affect the height of the other. And the last assumption is that the data set must be normally distributed, or there should not be any outliers in our data set. So these are the assumptions for the one sample t-test. For the first three assumptions, we can know whether it follows these assumptions without performing any statistical test. Just by looking at it, we know that it's a continuous. We know that a level of measurement is what is ratio, and the observations too are independent of each other. But for the last assumption that the data set should be normally distributed, We can't just know that by looking at the data set. So we need to find that using the normal distribution curve on the histogram. So how do we do that? Let's check whether this data set is normally distributed, and then we can proceed from there to perform our one sample t-test and interpret the result. So let's check whether it's normally distributed. Click on analyze, go to descriptive statistics, frequencies. I'm going to uncheck this one because I don't want the frequency tables. I only want the histogram. So I'll move this height, which is a variable of interest in this lesson. I'll move that one into the variables box. I'll go to charts because I want the histogram. Check the histogram. Check this box for show normal curve on histogram. Click on continue, then click on OK. So you want to see whether the data is normally distributed and the chart has been generated. You can see this bell-shaped curve which shows that the data is normally distributed. So once this assumption has been satisfied, you can proceed to do a one sample t-test. So let's look at how to perform the one sample t-test step by step in SPSS. You go to analyze, compare means, then one sample t-test is here. You click on it, then you move your text variable, which should be a continuous variable. You move it into the text variable box, and we have this field here, the test value. And the test value is the population mean, the one that we are comparing our sample mean to. So let's assume that a previous research revealed that the height of Ghanaians is 170 centimeters. So that is what we are comparing our sample mean to. Type 170 in the test value field. We can decide to uncheck this one, estimate effect sizes, because we don't really need it in reporting our results. But we can also choose to leave it. And if you want to specify the confidence interval, we click on the options, and the default is there, which is 95%. We are not going to change it. We are going to go with the alpha level of 5%, and the confidence interval is 95%. So you can just cancel it or click on continue. Then if you click on OK, and the results for the one sample t-test will be generated. So three tables are shown here. The first one is the descriptive statistics of our variable height. So we have the mean height to be 176.27. We have the standard deviation, the standard error of the mean, and you have the sample size here as well. But the actual result for the one sample t-test can be found on this second table, and what we pay much attention to is the p-value. Where can we find the p-value? It's here, the significance level for two-tailed, and it's 0.001. And the rule of thumb is that if the p-value is less than the alpha level, we reject the null hypothesis. So here we can clearly see that the p-value is 0.001, which is less than the alpha level of 0.05. So we are going to reject the null hypothesis, which says that there is no statistically significant difference between the sample mean and the population mean. The alternative hypothesis says that there is a statistically significant difference between the sample mean and the population mean. So if you are rejecting the null hypothesis, which says that there's no statistically significant difference, it means you are going for the alternative hypothesis, which says that there's a statistically significant difference. So that is how we conclude for this test. So the p-value is mostly used to draw conclusion or take a decision. Because it is the most simplest, you don't need to calculate any other thing again. You just compare the p-value to the alpha level. But we can also use the t here, which is the calculated t, and it has been calculated for us by the software. But for this t, we need to compare it to the critical t. This is the calculated t. We compare it to the critical t, and if this calculated t is greater than the critical t, that one to reject the null hypothesis. So let's see, how do you find the calculated t? We use the t distribution table or the student t distribution table. So let's find the critical t from this t distribution table. And what you are going to use to calculate the critical t is the degree of freedom and the alpha level. So the degree of freedom for this test will be 19, but the degree of freedom is equal to n minus 1. And our n, which is the sample size, is 20. So 20 minus 1 is 19. That is our degree of freedom. Then 0.05 alpha level for the two-tailed test. We will trace these two inside the table and you get our critical value, our critical t, which is the 2.093. So we are going to compare this. So we are going to compare this critical t with the calculated t, which we have here as 3.979. So we can see clearly that this calculated t 3.979 is greater than the critical t. So the same way we reject the null hypothesis, and we see that there's a statistically significant difference between the sample mean and the population mean. So that is how we take the decision with the t values as well. Apart from these two approaches, we can still use the 95 confidence interval of the difference to take the decision as well. And how we take the decision with that is that if the range from this lower to upper, if the range contains 0, we do not reject the null hypothesis. But if it does not contain 0, we reject the null hypothesis. So from 2.9 to 9 does not contain 0, because for it to contain 0, it means there should be negative and positive. So if the signs are the same, positive, positive, it suggests that this our mean value is above the population mean. That's why these values are positive, and it's all to the right of the 0, which suggests that it's higher and there's a statistically significant difference since the interval does not include 0. So same way, we are rejecting the null hypothesis, confirming that there's a significant difference between the sample mean and the population mean. So finally, let's look at the last thing we are going to talk about is how to report it in our research. So reporting in APA style, how we are going to report this is that a one sample t-test was conducted to determine whether the average height of Ghanaians differs significantly from the population mean of 170 centimeters. Data from a sample of 20 individuals revealed a mean height of 176.27 centimeters, and the standard deviation is 7.05. So it's a statistical significant difference of 6.27 centimeters between the sample mean and the population mean. And we report the t, a degree of freedom, and it's a calculated t here, and this calculated t is actually bigger than the critical t, showing a significant difference, and the p-value too is 0.001, which is less than 0.05. So that is how you conclude. We can also add the 95% confidence interval of the difference in the reporting if you want. What we say is that the 95% confidence interval of the difference range from 2.97 to 9.57, which confirms a statistically significant difference. So that is how we report, and this brings us to the end of our 5th lesson. Thank you very much for watching. See you in the next lesson, and don't forget to subscribe to this channel.